Everything in the universe, from this plant to this planet, is made up of building blocks called chemical elements. They're all represented here on the periodic table. But how are they organized? And what makes each group so special? Let's find out together in this episode all about metals, nonmetals, metalloids, and rare earth elements. The periodic table looks like this. It shows 118 different elements and reveals which elements are similar to each other. Each box represents one element. The periodic table is organized by row and column. Each horizontal row is called a period, while each vertical column is called a group or family. Elements that belong to the same group share similar chemical and physical properties. These properties are what we're going to be looking at today. If you break down the elements into four main groups, this is what the periodic table will look like. Here we have the metals, nonmetals, metalloids, and rare earth elements. These groups can be broken down even further, but this is the general organization. Why is this important? Knowing whether an element is a metal, nonmetal, metalloid, or rare earth element helps us to know how it's used in everyday life, and frankly, how dangerous it can be. The majority of elements on the periodic table are metals and share the following properties, with the exception of mercury, who apparently has to be special. We all have a friend like that. All metals are solids at room temperature and have high melting points. Metals are good conductors of both heat and electricity, so we use them in cookware, wires, and technology. Metals also have a shine to them, or a luster. Luster is fancy. Luster. They're malleable, which means they can be bent or hammered into different shapes for different functions. Metals are also ductile and can be drawn out into long wire. Only some metals are magnetic, so we say that metals can be magnetic, but not every metal is a magnet. The metals on the periodic table are grouped with other metals that have even more specific properties. For example, this group contains potassium and sodium, highly reactive elements. Potassium produces this colorful flame when burned, and sodium violently reacts with water. This small piece of sodium is forcing hydrogen out of the water, which causes it to race around the container. The metals in this second group are still reactive, but not to the same degree. Magnesium is so flammable that you can light a ribbon of it with a match. It burns with a blinding white flame. This middle group holds the transition metals. Three of the transition metals are magnetic: nickel, cobalt, and iron. Copper is one of the best conductors, so it's used in electrical wires. Titanium is named after mythological Greek giants called Titans because it's so strong. It's also very light, so it's used to make space and aircraft parts and medical joint replacements. Some of the transition metals are known as precious metals because they're quite rare and valuable. Gold, silver, and platinum are examples. This bottom row of metals are mostly man-made, radioactive elements. These three are named after planets. Uranium, Neptunium, and plutonium are highly radioactive. If you're still here liking this video, let us know. And hit that subscribe button so you never miss an episode. While most metals are found deep in the Earth's crust, Earth's surface and atmosphere contain mostly nonmetals. Nonmetals are a group of 17 elements located on the upper right side of the periodic table, plus hydrogen on the far left. Most nonmetals exist as gases, though some are solids, and one is a liquid. The nonmetals are pretty much going to be the opposite of the metals. They are generally poor conductors of heat and electricity, which is actually really helpful. Nonmetals are good insulators. We use nonmetals to protect ourselves against heat and electricity, like coating an electric wire with rubber or using a rubber mitt to take a hot pan out of the oven. Nonmetals are brittle when solid, which means that they break or crumble easily. They're also dull, which is kind of rude to say about them, but they do lack luster. Like the metals, the nonmetals can be sorted out even further. The last group on the end are called the noble gases because they are very stable. which means they're virtually unreactive. Helium is in this group, and because its density is so low, it allows this balloon to float. That's going to be up there a while. Xenon can be found in cinema projectors, giving us a bright and clear picture. The halogens are next in group 17. The elements in this group are highly reactive. Despite being toxic and extremely dangerous in their pure forms, they are essential in our everyday lives. Fluorine is used in toothpaste to prevent tooth decay, and chlorine keeps our swimming pools safe to swim in. The rest of the nonmetals are biological building blocks. Along with carbon, nitrogen, and phosphorus, they are the chemical foundation for all life on Earth, forming complex, stable bonds. My favorite element might be nitrogen, because liquid nitrogen is responsible for my favorite snack. Metalloids are what they sound like. Elements that share mixed properties of metals and nonmetals. They possess a unique combination of physical and chemical traits, such as looking shiny like a metal, but behaving like a nonmetal. Unlike metals, which conduct electricity perfectly, metalloids have an intermediate conductivity, which can be precisely controlled. They are semiconductors, which can be engineered to either block or allow current, which makes them perfect to use in modern electronics. Metalloids are also solid at room temperature and have a high melting point. They are brittle and crumble or shatter when force is applied to them. Pure silicon is too reactive to exist uncombined in nature. Instead, it makes up 28% of the Earth's crust as the second most abundant element, binding with oxygen to form quartz, sand, and rocks like granite. Because it's so abundant and an excellent semiconductor, silicon is used in tons of electronics like cell phones and computer microchips. Poor boron, with a name like that, how can it get any respect? Most commonly found in borax, the laundry aid, but it's also a key ingredient in silly putty as a cross-linking agent, giving the putty its unique viscoelastic properties, such as stretching and bouncing. Rare earth elements are a special group found in Earth's crust. Rare earth elements are highly magnetic and used to create the strongest permanent magnets in the world. Neodymium magnets are by far the strongest, most readily available permanent magnets. In fact, they're so strong, they're genuinely dangerous to be around, especially if you have more than one. They're so strong that they can snap together with enough force to break a bone and pick up metal objects 1,000 times their own weight. Gadolinium compounds are injected into humans as contrast agents for MRI scans. It responds strongly to the magnetic fields in an MRI machine, which means if you inject a specific form of it into the bloodstream, an MRI can show you just where the blood-containing element is and isn't. It sounds bizarre, but it's pretty amazing. This helps doctors locate possible internal bleeding or a blockage. Knowing more about these elements helps to understand how they're used in everyday life. So the next time you travel in a plane, think the metals like titanium, or enjoy a good movie. There's the nonmetal xenon. Metalloids like boron and silicon give us silly putty and cell phones. And rare earth elements like neodymium can freak us out with their magnetic force. If you want to learn even more science, you can check out this video next. Oh my gosh, mosquito in my eyeball.